Greetings. What we've got here today are two Noco GB70 booster packs. They're lithium ion jump starter packs. The labeling is different between the two, but they're both the GB70, so as far as I can tell it's just a label change really between the two. They're both here because they don't work. This one will not. You should be able to start this up with no battery connected and use the 12 volt output on the side to run. It comes with a lead which has a 12 volt charger which will run off a cigarette lighter, or it can run the cigarette lighter socket, this lead. You can see there's a cigarette lighter socket there and a cigarette lighter plug there, and these are connected to these recessed DC jacks, so you can either run it as an output like that, or you plug that to the input instead, and you can charge it that way. Or you can charge them again. It's also got USB, so it can charge on USB. It comes with a micro USB cable, and it's got a USB output as well, so it can be used as a great big phone pack. These are 57 watt hour, I think it is. Yeah, 56. It's a 56 watt hour pack. This one doesn't start at all. Won't run the torch, won't do anything. If you try to charge it on 5 volts on USB, it'll pull 1/4 of an amp. If you try to charge it on 12 volts, it pulls around about the same, but it does get a hot spot around here as it's charging, as it's allegedly charging. This one pulls about 1.5 amps on USB, or again I think about 0.5 amp. In fact, I think this one draws next to nothing on 12 volts. This one pulls about 0.5 amp, and this one you can't wake it up, but you can turn the torch on. It's got a built-in torch on the end, and you can turn it on and off. If the torch is on, I can't remember if the USB output is on at the same time. Let's just, no, it's not. The USB output is on if it's actually being charged. You can see it is fully charged because I've fully charged it, but it does not want to wake up. Torch, by the way, if you knock it on and try to knock it off straight away, it's got different brightness settings, and then it's got flashes, and then it goes off. Or you can turn it on, and if you try to press it again after a couple of seconds, it's back off. So let's take a look at this one first. This one, the completely dead one, we'll put to one side and take a look at that later. Let's get these cables out of the way. It uses 6 triangular, they're not exactly tri-wing, they are triangular screws. Let's take a look, see how easy it is to see inside. See if we can figure out what on earth is not right with it. Now inside we can see we've got a connector there which is marked up as NTC1, so that's going to be a thermistor. Then we've got the balance connector, and we've got a relay connector here which is soldered on the relay itself and plugged in on the board. That will be of interest later on. Oh, is it? Oh, what have I got here? Oh my god. Oh my god. There's a wire there. Why is that heat shrunk? Where's that supposed to go? Is that supposed to go anywhere? It's not got anything on it. Right, I'm going to take out these connectors here. A little bit easier to work with. So let's unplug the relay board and balance plug and the NTC cable. Let's us actually tip this over some more and see what's what. So we've got an extra thin cable there which goes nowhere, and I can't see anywhere on the board where that would go. So maybe that is actually heat shrinked up for a reason, and the pack is for use on a different unit. So let's flip it that way. I'm not being as careful as I should be here, because this board is actually still live. It's got a battery connection on it, even though the board is now dead to the world. It does have power to certain parts of it. So let's see what we've got on the individual cells. Let's measure across the terminals here. 4.15, 4.13, 4.14. Pretty well balanced. The battery itself, Big Clive has taken a look at these. I don't think it's 18650s. I think it's a big fat pouch cell, I believe. Some very high current connections on the end. You can see there's actually a bus bar coming off there, off this end, connecting to one side of the relay board, and the relay board is basically held in place by that bus bar. I suppose what I should do is test that. Let's see what voltage we get between the terminals in here for the battery and here. 12.42. So there's plenty of power there ready to set fire to this thing. I'm not seeing anything else untoward in here at the moment, so I'm just going to go ahead and plug it back in just to see if disconnecting it and reconnecting it has given it a chance to reset. And I should mention at this point, there's another channel where a fella's taken a look at a couple of these. So if you want to take a look at the SOSfix Electronics channel, you'll see where I got some inspiration for at least taking the lid off this thing. So we've got relay connected, that's connected, that's connected. Nothing else has been messed with. Let's see, does the torch work? Yes, the torch works. Right, torch off. But it still doesn't want to start up. Now, could it be that the button, could it be something as simple as the button not working? Let's find out. let's take these connections off again. And dive a little deeper. The button is a surface mount job, it's not through hole unfortunately, so I've got to get this board out. And this involves another triangular screw here. And the rest of the screws on the board. I'll find the right screwdriver, there we go. There are 3 Phillips screws holding the board in place. There we go, wiggling it up and down a bit and I should release it from there. There's nothing else actually screwing in it, it's purely a friction fit. So we've got the board open and it's got all this gunk inside. Right, this button. So these contacts are connected directly to each other. These are the actual switching contacts. And it doesn't appear to be switching. It looks like it's got a dead switch. That's a nice and easy fix, hopefully. Let's just check the other ones. Yep. Yeah. It's a dead switch. I'm going to dig through my parts bin and see what I can find. Let's see if I've got one that will fit. Which will see if I can actually buy one. Now, of course, there are 2 ways of having this close enough to the button push in there. One is to have a switch like this with a long enough stalk. The other is to have a switch like this with a short stalk but long enough legs. And to remove this, all I'm doing is I've flowed some more solder on the switch. So now I'm alternately heating the legs of the switch whilst putting a twisting motion on the switch itself to raise it off the board. Switch back that way, not least because I am right-handed. Dead switch out. And the legs bent out slightly. I'll just bring those up. You can see I bent the legs out slightly there. It's actually very similar footprint to the other one, and also it's the same, pretty much the same height. Did you notice earlier on actually, there's actually a 30 amp fuse in here, and that fuse is soldered into the board. So if that fuse blows, what do you expect it to do with this? Why isn't it just underneath the rubber cover so that if the fuse blows you can take it out and replace it? mean, to be honest, I don't know what the fuse is for. It's certainly not going to be for the 2000 amp jump leads. But still, if that thing blows, how are you supposed to replace it? Right, that's the board down. Now these leads, which insist on wrapping around each other, right, that's supposed to go like that, I think. And you've got this red lead which tucks in down there. So then you've just got that over to there, and because that is a little bit shorter than the other ones, I'll plug in the NTC and balance lead first before plugging in relay board, and that then goes like that, and everything sort of squishes together unless you've messed something up. It all, yeah, it's very tightly packed. I'm trying to pinch the cable there then. So what's stopping it? Oh, there we go. I think, there we go, it's catching another cable. That is shut. Okay. Yep, torch works. Let's torch off, try powering up. Yeah, we've got power this time. And we heard the click of the relays then, so I assume those are those live? Only 0.3 volts on there. I think that's fine, because I think what it's actually doing now is actually running its 12 volt and USB outputs. If I plug that in, do I get power from that? Yeah, so that's actually running as a power pack now. I'm gonna turn it off, put the rest of the screws in, and then I will test it with the battery connected, and I'll test it actually running as a, with its emergency bypass mode, where you can actually use this to power a car without the battery connected. You can just force it to turn on its terminals, or so I've been told. Now this battery's voltage is 12.67, so we'll see if it does anything now. Might see a difference when it turns on. Cycling through. Is that normal? I don't know. It does have that mode. doesn't want to do anything at the moment, but whether this just doesn't like having a battery that's possibly got a higher, let's just drop that. Yeah, its own voltage is slightly lower than this battery, so it seems to be disconnecting itself. See, it's got a 12.4 before dropping itself back out. But this then should force it on, I think. Let's try that. Maybe, there we go. 12.4 volts out. So that's forcing it to run now, regardless of whether there's a battery connected. So this should actually be able to jump start a car even without its own car battery fitted. So I think this is actually working. Right, let's take a look at this one. The second one I've opened up, and the first thing you can see is these two wires have come off the connection in here. So I'm going to have to take the board out and resolder those in. I could probably solder them in on the top, but it'd be a bit fudgy. If I can get the board out without too much difficulty, I'll do that. The whole board is very tight here. It feels almost like as though it's held in by another screw. It isn't. You just got to tease it. Oh, there we go. Once you get that top one up, the bottom one gave way fairly easily. Now I've got to be careful here because there are still live connections on here. The battery has a raw connection there and there, so this board is at least partly energized. Anyway, for now, with that reconnected, and obviously this is disconnected, so it's had a chance to clear its head, if you like. I'm going to put it back together and see if it's made a difference. See if it'll now boot up without any batteries connected and actually function like it's supposed to. Now, before I put it back together, I'm going to measure across the cells, see what we've got. Be careful not to short them here, because obviously this is connected directly to each cell, and it would not take too kindly. That's 4.03. 4.03. 4.03. It's a good sign, I suppose. This has a hook there, so that hooks in, and that is how it's fastened in place. Same thing goes for this side, which is now feels like it's around the wrong way, but it's not. It's just upside down on there. There we go. That goes on. I can go there. There's a toroid there. That toroid I don't think needs to be flat. I think it needs to be flat up this way. So that was getting in the way. He was getting bent down. So that's now out of the way. Is it just that? Yes, it was pretty much. That may not be easily visible to the camera because it's not very bright, and to those moaning at home, you can't adjust the brightness on it. So that's showing 5.11 volts. At 0 amps. Let's plug it in, see if it'll pull anything at all. It's pulling 1/4 amp. It doesn't want to wake up. Let's see what we get with these switch contacts. So, well, it ain't the switch contact. So if it's not the switch contacts, what is it on this sea of gubbins? There are lots of low value resistors worth checking. So yeah, there's nothing obviously wrong with it. I think obviously there's something wrong with it, but there's nothing obviously wrong with it. A bit of telltale magic smoke would be nice, but there's nothing in the case. Powering this board up with no, well, bare minimum of battery connected, if you like. It's not got the battery balance lead or the other one. So let's just see. Again, 1/4 of an amp is all it's pulling. Interestingly, with no battery connected, this doesn't make any difference. I have tested off camera, and with it all connected, the power draw was dropping from 1/4 an amp down to nothing if you actually pressed either the on-off button or the flash button. Which of course obviously means, I'm thinking about it, these buttons are fine. So I didn't need to take it apart to check the buttons. So there's 5 volts there. Does that mean there's 12 volts over here? Yes, it does. So what we've got now is the something was getting hot there. That regulator is getting hot. Or at least I think it's a regulator. That component there is getting hot. So we've got the 3 volts, sorry, we've got the 5 volts coming in. That is running the 12 volt bus. That's getting hot. So what's upsetting that? Well, we've definitely got a hot spot. Let me just see if I can get that in focus. And try and point it out with something relatively benign. That there, that. It could be the heat is all radiating from this. Or is it this? That's, ooh. The heat is not radiating from this, because that is getting even hotter. And that is D2. Yeah, D2. It's getting very hot. So let's power that down. And of course it could be that the regulator is drawing too much power through D2, and D2 is getting hot because the regulator is dragging it down. So there may be nothing wrong with D2, and it may be the fault of the regulator, or maybe the fault of D2, or it could be something downstream from the regulator that's causing it to all go wrong. So what's upsetting D2? I'm getting half a volt in both directions on that. Let's try D9. .2 in one direction. I'm going to take D2 out of circuit. Well, it ain't D2. D2 appears to be behaving properly. So it's not D2 that's at fault. There's something across D2 which is potentially at fault. And like I said, it could be that regulator is packed in. That looks like it might be a bit of a pig to shift because it's got a tab. It's going to take a bit more heat to actually shift that off the board. Not least because the tab is meant to dissipate heat, so it's going to be on quite a bit of copper. It's not going to be just there for show. I can try waking it up. I doubt it'll do anything. Obviously I've removed a component now. So let's see what happens if I do. To get the lead in the right way around. There we go. Power draw is now 0.02 amps. Nothing wants to wake up. I can confirm that we have 5 volts here. We have 12 volts there. We have 5 volts on one side of D2. Nothing on the other. So it looks like that diode provides a forward voltage of 5 volts, presumably towards the regulator. If the regulator is failing, or if something is pulling too much current out of the regulator, then the regulator is getting hot and the diode is getting even hotter. So there could be a fault further down from the regulator, obviously. We did see, I think we did see something else getting hot, so I'm gonna resolder the diode. I'm gonna disconnect the power, which is still at 0.02, and I'm gonna disconnect the I'm gonna resolder the diode, which I haven't lost recklessly, and let it run again and see what else is heating up besides these two. Okay, so if I power that up again, I know there should be 5 volts on that diode from here. So let's get some juice in again. Pulling 1/4 amp. 5 volts. And we have just over a 1 volt drop across that diode. Just coming in by the looks of it at that side of the regulator. So I'm assuming this is a regulator. All I'm seeing here is 3.98, 0.1, 0, and 3.98. 7533-2. Let's look that up. And that is a Holtec 3.3 volt low dropout voltage regulator. It should be putting out 3.3 volts on this pin. 2 reasons why it might not be. One is that it's dead. The other is that it's trying to, but it's getting dragged down by something else. Can we find with the thermal camera that something else? Are we seeing low resistance to ground at that point? Let me just try. Just check there's no voltage there before I do the resistance tests. Yeah, that's almost a dead short to ground. Why is that almost a dead short to ground? Basically across those caps. And across that diode. Let's remove a few more components, I think. It's worth trying to fix this thing at least. It's not that which is showing at about 6 microfarads. Let's put that to one side. Check we still have board short. Let's remove another cap. Just because they're relatively easy to remove, and it'd be a nice quick win if it did turn out to be a cap. So it's not showing like an overheated cap, but it's not showing an overheated anything apart from the regulator, so it's a little bit of a straw clutching exercise in that regard. Not showing up as a short. The board still has its short. Still shorted. Yep. So it's not the regulator. diode out. Now it is a Zener, so it could be that this thing, now then again, even if it is a Zener, this shouldn't be detecting a zero short. Well, there we have it. Not even getting hot. But that's not all. We've still not found the fault. It's showing 6 ohms now. That's different. That's changed since removing that. Okay, so, well, with the obvious short out of the way then, if I refit the regulator and the 2 mini caps out of the set, will it actually allow then, without that dead short of that diode, will it allow the fault to reveal itself or burn it? Well, it shouldn't burn itself out, not at how little current the regulator can deliver. And I'm seeing 2 volts on the regulator output now instead of being dragged down to 0.1. Just confirm that. 2 volts on the output, 4 volts on the input. That voltage is now 2.9 volts. Just check at the side of the regulator. Yeah, 2.9 volts. Back of D2 is 5 volts. Front of D2 is 4 volts. Output from the regulator is 2.9. So it's on its way up. Current draw is 0.14. Does the fault have the potential to burn itself clear? I don't know. Okay, it's been running a little while now whilst I took the footage from the camera and put it on the computer because I ran out of space. And measuring the voltage, the resistance across the capacitors now, it's risen now to about 20 ohms. So it's almost as though the fault is slowly getting, I don't know, burnt out. The current draw is now down to 0.12. That light is flickering. There's another light which has been flickering as well. One of these other status lights has been flickering very weakly as well. The voltage from the regulator now is up to 3.145. So it's better than it was. It was around about 2.8 and then 2.9. So it's up to 3.1 now. Wow. Now, weirdly, it seems to think it's charging. Or at least that's what it claims to be doing. In fact, it is charging. But it's not now. So that's not good. Right, we've still got that 20 ohm short, but at least we've got a Zener back in place as 5.1 volt Zener. Yeah, something's definitely not right with it. It's an understatement. I mean, it's charging itself. It's a self-charging booster pack. Perhaps it should have a Toyota or a Lexus badge on it now. Now, the handy thing about having 2 of these to hand, obviously with one working, is that if you find anything strange about one, you can try and use the other one as a reference. For example, I've got this lead connected to the input. So this is for charging normally from a 12 volt supply. And I can put Put these meter probes on there, and you can see when I switch it on, there's 0.02 of a volt on the input to this, which is fine. You wouldn't expect to be putting anything out on there. If I do that same connection on this one, just reconnect the battery. Connections here. Let's wake it up. Why have I got 9 volts on the input? That's why I think this is flashing that it's charging. As far as it's concerned, it is charging. Try and find out where this is getting 9 volts from. I'm getting a short across that diode. Yep, that diode is a dead short. Right, what can I replace that diode with? Yeah, it's a bit big, that one. Okay, what I'm going to try using is this 1N4001, just a bog standard 1N4001 diode. Miraculously, I'm actually going to be using a new one rather than just salvaging one of my many scrap diodes. I'm going to use a brand new one. I've put some insulation sleeving. I've stripped some wire so I can nab the sleeving for this. And the reason for that is because the LEDs are right along this area, so I can't just fit a big diode in there without knackering up the way the case comes together. This allows me to actually park the diode a little bit further away. Well, that's more promising, isn't it? Let's put that to volts. I think. Let's try the boost. Of course, it can't do the boost at the moment because the relays aren't connected. Well, that one can. It can't do this one. I think that has actually been fixed. Let's put it back together. There we go. Two happy jump starters. In fact, this one is probably only too happy to charge from this one. Like that. So, hope someone found that interesting or useful, hopefully useful. Check out the link in the description for where you can see more repair videos on these by SOSfix Electronics. And I'll catch you again soon. Thanks for watching.